Next problem. Next problem is you are given this derivative. Find its relative extremum for f. You are given derivative. Relative extremum means relative maximum or minimum. Relative is also called local. Local max or minimum. How do you get local max or minimum? You need to find the critical numbers. How do you find critical numbers of f? You need to find its derivative. Aha, but you are given the derivative in your question. Okay, so there is no need to find anything. You have been given the derivative, first derivative already. Okay, so I've been given the derivative. To find extremal points, we need critical numbers. Number is critical if the derivative does not exist or derivative is 0. Notice my derivative is a polynomial. If I multiply it out, it would be a polynomial. So derivative will exist everywhere. Okay. So does not exist is irrelevant for us. We need derivative equals 0. Derivative is 0. So this polynomial is 0. Well, we already have a factored setup here. The first factor gives me -6. Second one, notice how it's written, but it still gives me x equals 8. This gives me x equals 17. So, these are my critical numbers, -6, 8, and 17. So, do I get extremum at -6? Do I get maximum or minimum at any of these? Well, how do we know? We have to find where it is increasing or decreasing. So, my first interval is -infinity to -6. Second interval is -6 to 8. Third interval 8 to 17. And last interval is 17 onwards, 17 to infinity. So choose any number from the first piece. I've chosen -7. Who will be? You could have chosen -10, whatever you like, but something here. Then choose any test number here. I've chosen 0. 0 is usually easy to work with. Choose something here. I've chosen 10. Choose something here. I've chosen 20. Plug these numbers in the derivative function. Okay? We don't care about the value. We care about the signs. If I plug in -7, -7 here gives me an overall negative. Whereas here, because it's -x, minus of -7 will make it positive. This is positive. Same story here, positive. So negative, positive, positive. Overall negative. You see, I only care about the sign. Same thing, plug in 0. I get positive, positive, positive. Overall positive. Plug in 10. Positive, negative, positive. Overall negative. 20. Positive, negative, and a negative. So overall positive. So now that you have these signs, when derivative is negative, f is decreasing. Derivative positive, f is increasing, and so on. So, on the first interval, my f is decreasing. Second interval increasing. Third interval decreasing. Fourth interval increasing. Mind you, you do have to use test numbers. You're not guaranteed this alternative behavior. Okay, decreasing, increasing, decreasing. That doesn't always happen. Without test numbers, you don't have these guarantees. Okay. Well, what's the point of this? -6 was a critical number. 8 was a critical number. 17 was a critical number. To the left of -6, I'm decreasing. And then to the right of -6, I'm increasing. So in other words, -6 is going to give me a local minimum. Likewise, 8. To the left, I'm increasing. To the right, I'm decreasing. So 8 is going to give me a local maximum. Likewise, 17. So mind you, I don't know where these curves lie, far above or far below. I don't care. I only care what happens to the shape. You see, 17 to the left I'm decreasing, to the right I'm increasing. So left of 17 I'm decreasing, and then I start increasing after 17. So this gives me a local minimum. Okay. So my numbers are -6 is my first one, and it has a local minimum. Second one is an 8, and it has a local max. And 17 is the next one with a local minimum. Okay. Inflection point. Looks like I have typed in something already. Let's see. The inflection point you have to worry about. To obtain you need second derivative first. Okay. You were already given first derivative, so find the second derivative. This calls for product rule. Derivative of the first, the rest as it is, plus derivative of the second, look, that's a -x, so -1, the rest as it is, plus first two as it is, times derivative of the third. Okay, so this is 8 minus x, 17 minus x. That minus brings me a minus here, x plus 16 and 17 minus x. That minus is also there, and x plus 6, 8 minus. Notice x plus 6 and a -1 are common in both these terms. So that's why I have a negative and an x plus 6 outside. Whatever is left in this particular term, 17 minus x is left, and in this particular term 8 minus x is left. Now this gives me 8 minus x, 17 minus x, negative x plus 6, simplifying 25 minus 2x. Now at this point I have multiplied them to get this. I have multiplied these two factors to get this, keeping track of the minus in between. Now distribute the negative. Presumably everything is correct, and I get a quadratic. So, because it is a quadratic, I know that I'm going to be a parabola. My second derivative is going to be a parabola. X-intercepts will lie on the x-axis. Yes. How do you find x-intercepts? That's what it means to have solutions of this equation. So this is a quadratic. I have simply used the quadratic formula. Minus b plus minus square root b squared minus 4ac over 2a. Yes? So I have simplified this and I get this particular expression. So that is my one x-intercept. That's my second x-intercept. Parabola, therefore, notice parabola opens up because of this 3. It's a positive. So I really don't know the values, but I know the picture is going to look something like this. The point is, to the left of my first x-intercept, I'm above x-axis. That is second derivative, which is what all of this was. Second derivative is positive to the left of x1. Second derivative positive means f is concave up. Between x1 and x2, my parabola goes beneath the x-axis. That is, second derivative is less than 0. That is, my function f is going to be concave down on this interval. After x2, parabola goes up. So my second derivative is above x-axis, that is it's positive, which means my original f is going to be concave up. So you see concavity changed from x1 to the left of x1 to the right of x1. Likewise, concavity changed again, left of x2 and right of x2. So x1 and x2 are going to give me inflection points. Okay. So what was x1 and x2? One was with the negative, the other is with the positive in here. Okay. In here. So let me write down. First inflection point occurs from the left, right? So I'll write this expression. It is just something over something. Denominator is easy to fill. I'll write the 6. Numerator. Let me make a whole bunch of space. Don't forget, everything has to be in the parentheses, right? So what is it? 38. The first one has to be the negative part, minus square root. Okay, square root has its own parentheses. Okay, and then I have 38 squared plus 4 times 3 times 14. 4 times 3 times 14. Okay, all of that is the numerator. Okay, so this is my first solution using quadratic, and the second solution using quadratic is essentially the same, except of the minus. I'm going to have a plus. So where was that minus? It was just before the square root. So that's a plus. Submit. Everything is good. Okay, until next problem then.